on the Facebook comments as well, so you guys can have the notes if you're watching on Facebook. It's all you.
Thanks. Okay, great. So yeah, as Jennifer said, my name's Paige. A little bit more about me. I'm I guess by trade, like a full stack, what's called a full stack software engineer. So I just do all kinds of things with web development. I've had 4 years of experience working for a financial software firm. And I've worked remotely for most of that time. So I started working with the library, doing programs to teach people how to code in the community and at large. So it's been pretty cool to do that. And so I guess we're continuing, which is great, even despite, kind of COVID surge, we can do this stuff remotely. So that's really cool. I'm glad to see so many people joining. It's really exciting. This series in particular is going to showcase basically my knowledge about making games. I've done a little bit of, with game making in the past, but I'm also pretty new to some of the stuff we're going to talk about today. So that's kind of exciting for me. So I hope you get something out of this, and the series will basically try to get you going, get you feeling comfortable with sort of the vocabulary of game development and sort of what's out there and what's involved. And also we'll try to produce a small game, which may not be the most, fun game you've ever played, but it'll be maybe for some of you, your first game, and it'll be a good place to kind of understand certain concepts, and maybe you can even extend it for yourself. So that's kind of what we're setting up for this series. So I'll go ahead and first thing, let me share my screen. If you're just joining, Jennifer posted about it on Facebook, but if you're in the Zoom, you should be able to see a link in the chat. Try to go to that link if you can. That's basically going to be the hub for the series. I'll post all of the session notes. I'm going to post code once we produce that through the sessions, and I'll post other items there, like mainly just the notes. So anything we cover in the session, for the most part, you'll be able to see that too. So that's that's definitely really helpful. If you go to that link, I'll start sharing. Actually, Jennifer, could you enable screen sharing? Seem to be disabled.
Sure, give me 1 second. I think I'm just gonna have to make you the host.
Oh, sure, no problem.
Which will be fine.
So yeah, if you go to that, oh, great, thank you. Okay, let's give it a try. Great. So I will just share. Let's see, well, what can I share? I will share. That's fine, that's fine. Okay, yeah, I'll just share the whole screen. Okay, so everyone should be able to see my screen now. And you should be able to see a web page where basically we're going to look at the notes. This is how I typically do notes for these kind of series with the library. So everything's kind of posted here. So I'm going to go over this loosely, but the main thing here is that this is for your benefit. So it's hopefully a good resource for you to kind of refresh anything we talked about, and anything I mentioned should be in the notes. So, if you forgot something, stuff like that. But I'm not going to follow it religiously. One thing I do want to mention before, though, is that if you go back, this is the link I sent in the chat. This has my office hours link. So I have office hours with the library every Monday. Since we're fully remote right now, these office hours are fully remote. You can basically go to this calendar link. You can click here, and any Monday, you can select a block. And I'm happy to talk to you about anything. It doesn't have to be about making video games. It doesn't have to be about, any one sort of coding or programming subject in particular, I can try to advise you or discuss with you all kinds of different things related to programming. I mean, most of my knowledge lies with programming. So, if you're like an entrepreneur or something like that, there's definitely other resources at the library to help you with that. But if you have coding questions, bring them my way. I'd be happy to talk about them. So yeah, these are on Mondays, but if you have like an extenuating thing or really this time just doesn't work that well for you, you can send me an email at this address right here, coder@nhfpl.org, and I can answer questions via email. We could also set up in a time that might work better for you. So that's no problem. Okay. All of that out of the way, if you jump so if you're on this webpage, you can click session 1 here, and that's today's session. I should probably date these, but I can do that later. So, and this is kind of where we're getting started. So I think what I would say you'd need for this session in particular is just a web browser. If you have that, then you're good to go. You can kind of follow along with the links. But don't worry about downloading any of this stuff, right away, unless you're excited to do so. In which case, you can jump ahead and you can see which one we're going to download. It's going to be right here, so you'll be able to see this download. Yeah, but anyhow, getting started. So obviously, we're talking about game development. So I wanted to kind of address the stuff that we're going to be covering sort of in this series, or today specifically. So we're going to learn about game engines. So like what a game engine is, because that's what you work with, what you develop with. It's like your primary tool, sort of, when you make a game. We're going to learn about scripting. So scripting specifically for video games. We're going to learn how to set up your get started with developing on your computer, and then we're going to start. We'll try to start a project just with the engine that we've selected. Okay, and I'll just. Oh yeah, that's right. Okay, so yeah, if anyone has any questions, by the way, I don't know if everyone heard, but you can, of course, interrupt. There's no problem doing that. You can. I think you can raise your hand, or you can send a chat, and I'm happy to answer any question, yeah, that you might have. So feel free to interrupt me. It's pretty loose. Okay, so the first part is, what is a game engine? I mean, I think probably if you're in this series, we don't really need to cover what a video game is. Probably everyone kind of knows what a video game is if they're joining, or loosely knows what a video game is, certainly probably played them, but you might not have ever heard of the term game engine, or you might not be familiar at all with what it is. So, I provided this kind of link really quick so we can open that up, which is just a Wikipedia article for game engine. But basically, they're going to use a couple of pieces of software terminology, which I can break down even further to sort of explain this a bit more clearly. But Wikipedia calls it a software framework designed for the development of video games and includes relevant libraries and support programs for doing so. So basically what that means is, if we want to make a video game, we're trying to write software. That is the basis of making a video game, is writing software. But a video game is a specific piece of software, a specific type of software that has a whole host of problems that it's trying to address. And thankfully, when you're making games, everyone's pretty much trying to solve a lot of those same problems. So if I'm making a calculator software, there's probably not a bunch of software out there necessarily. There could be. I might be speaking ahead of myself for making calculators. It's a pretty unique objective. So if you're trying to write that kind of software, you would need to build a lot of the things that you'll need from scratch to make your calculator. So you can display the numbers, and so you can do all of your computations and do them in such a way that works for what you're trying to design. Well, for games, for a long time, people have basically written software such that making games is easier, and such that it's somewhat uniform. So every time I make a game, I don't want to have to remake, all of the graphics. I don't want to have to recode the way that the computer displays pixels on the screen. I don't want to have to recode all of the sound, like the way that sounds play in the game, stuff like this. So game engines are basically just a big suite of tools written in software that kind of wrap up and make much more accessible the big sort of chunky things that almost every game is going to need, like sounds, like rendering or graphics, etc. So that's what a game engine is. An engine, as they mentioned here, is something that comes up in software generally. It's just an engine. You can think of it just like you would for like an automobile. It's basically what makes everything work. So you have a video game. The game engine is what makes that video game work. Yeah, that's basically the gist of what this is. So, and yeah, these things come up over time, either within maybe a company. So certain games produced at certain companies, they work with a specific engine that they've worked on maybe internally. Like, for example, there's the developer Insomniac. They made the Spider-Man games. So they have their own internal engine that they work on, sort of in-house. And all of their developers work on that engine and use that engine to make their games, so that it's easier for them to make games over time. They can control everything that's sort of going on. And of course, engines get developed based around what's interesting to people. So, if a new game gets made, it introduces some new concepts that players are excited about, or developers are excited about, then engines that the public has access to, that developers have access to, they'll try to incorporate that. I pretty much covered all this, but engines address problems with making games. So the idea is like, we're trying to make a game and there's all these problems in front of us. So for example, agents are a really common problem in games. That basically, you should think, when you see that word, you can think NPC, non-player character, if you're familiar with games, or basically enemy, or just something in the game. It could be a person, like that isn't played by anyone, and it's just kind of roaming around the world. It's interacting with the player. So I pulled up this. I found this article. It's pretty cool. It's about this tool that was made by the company Unity, which is a very, very popular game engine. We'll talk a little bit about it. And they made this whole tool set, a big piece of software, which you can use in your own game if you wanted to, that has a bunch of machine learning trained agents. So, an agent is basically just something that is responding to the world. It might learn about the world, it might not, and it interacts with other, actors or agents in the world around it. Agents can be really stupid, or they can be really smart, as smart as you want to make them. And these agents are based around machine learning. So this is a pretty interesting article. You can kind of see, this is like a minute-long thing. So they're demoing this agent. This is like it's a machine learning model that they use for this dog. So basically, you play with the stick, and the agent, the dog, is going to respond and interact with the world based on what you do. So this is a really common desire when you're developing a game. You think, oh, like, I have my player, but I want other people in the world. I want them to interact with my player. I want the world to feel real. So we use agents to do that. Game engines often provide a way for you to create agents all of the logic around, oh, what should I do if this happens, or if this happens, or if this happens. They have built-in sort of software interfaces to let you do that more easily. So you don't have to rewrite all of that code every time you try to make a new agent. So this is pretty cool. It's just, a pretty simple, I mean, I don't know if I would call this incredibly, exciting looking. I think some of the demos further down are a little more like thrilling, but nonetheless, I think it's pretty cool. That dog is basically interacting with the world. You don't have to write any code for it to do that, really, or especially. So that's pretty cool. So physics is another thing that a game engine should be able to handle typically. And the question you should be asking if you need a physics engine within your game engine is, how do I handle forces and collisions in my game? So the answer is with your physics engine. Physics engines are probably the most sort of touted aspect of a game engine. Usually when you're like looking at new games, that and graphics rendering, but looking at new games, seeing what's possible out there. This is like, physics is what a lot of people get really excited about. Like, what makes something look really realistic? What makes something feel really good when you play it? If the physics engine is really good, and a lot of breakthroughs have been made over the years with physics engines. So games now have, some incredible physics engines that make everything seem, hyper realistic. I just wanted to show this example, first of all, to add some levity, but also just to show an example of what a physics engine is responsible for. It doesn't necessarily mean that it's always going to be great. So, when stuff like that happens, that's not exactly what you hope your physics engine is going to do. But, that's why it happened, is this physics engine is really weird. And I guess this guy shot the bus and it just flew into the sky. So that's because of the physics engine. Why it happened, it's hard to say. But, that's what's possible with the physics engine. So this game is Fallout 3, which is a pretty old game now. Now it's 10 years old. So, okay. So yeah, the objective there is to handle forces and collisions, and this isn't just limited to 3D games. You might bring to mind 3D objects floating and flying around in space when you think of a physics engine. But 2D games have physics too, right? Physics can be as simple as I walk up to a door and the door responds to me hitting it, right? So in an XY plane, if I'm moving around my character and it hits walls, what happens? A wall should stop my character. Can my character go through walls? These are interactions with the physics engine. Okay. Moving on, I mean, basically, you can kind of address tons of different questions and concerns within your game engine. And depending on the engine, it might address a multitude of concerns. Some game engines really try to be a complete ecosystem for the developer. They would really prefer that you only use that game engine rather than having to use a suite of other tools in order to solve certain problems. So sound, how do I get a sound when my player does this? Graphics, how do I update the screen, draw things that are happening in my game, networking even, if you want to make a multiplayer game, and so on. I mean, there's tons of different things. You can see a nice comprehensive list back at the link I gave here. So talks about all different things that might be addressed by a game engine. Yeah, so moving on to that, how do you interact with a game engine? And really, like, what is, I mean, I've told you what a game engine is, what it does, what it attempts to do, but like, you don't really know what it looks like. We haven't really seen one yet. I'm gonna quit this because we're going to use it. Here's a little sneak peek. Anyway, so that it opens fresh in a few minutes here. But yeah, so how do you interact with all of these different software capabilities that the engine provides? How do you begin to solve problems using the engine for your game? Usually an engine comes with a UI or a user interface, graphical user interface, GUI. And the idea there is that basically the game developer opens the engine. The engine includes all of these things, these software tools, but it also includes a way to interact with those tools with a graphical user interface. So oftentimes you'll hear people talk about working with a game engine. They might be talking about just the UI that allows them to expose those tools. So an engine is kind of all-encompassing, an all-encompassing term, really. But traditionally, it used to mean just the code that was running, handling physics interactions, handling sound, etc. There might not have been a UI. So programmers really were just calling pieces of code with their code when they wanted to add custom custom interactions in their game or behaviors. So nowadays, engine kind of means just like everything. You can think of it like, Photoshop is like an image engine, sort of. It's a very specific engine for generating images, editing images, and it has a UI so that you can interact with all those tools. So you can kind of think of it like that. And of course, the secondary aspect of this is going to be the programming and scripting aspect of the engine. So, to make games as it is today, there are some game engines that are pretty robust in their own right, but are going to be limited inherently. But as it stands today, making games, you need to learn how to code to some degree. So you're going to have to get prepared to write some code at least, and that's where scripting comes in. So most game engines provide what's called a scripting environment or even a scripting engine, and basically what that is it's going to allow you to write code apart from the engine, right? So the engine is handling generic problems like what happens when a ball falls to the ground, what sound does it make, does it bounce, like things like this. But your game is going to be specific. You're going to have certain rules within your game. You're going to have certain behaviors that you will want to describe. And the engine's going to help you do that, but you're still going to have descriptions of these events that are specific to your game. So let's say your game, involves a deflated ball. The physics engine might possibly allow you to render a deflated ball. It might already know what a deflated ball is, and so you can just use one out the gate. But if it doesn't, and your game is very important to your game, then you'll have to create the idea of a deflated ball, and you can do so with scripts or with scripting. So the scripting engine that is hosted within a game engine is basically going to run your scripts, and it's going to interact with the other layers of the game engine using your scripts. So this is pretty useful, and it basically is what makes your game your game. Like when you start writing scripts, it makes your game unique to the way you've written them. And we'll look into it a little bit more, but yeah, like I said, they're going to host the content of your game. So, if player A shoots player B, then, some points should increase for another player. This would need to be scripted. So you would need to script this behavior. You need to tell the engine to run your script every time something specific happens in the game. So yeah, that's kind of hopefully a decent overview of a game engine. Obviously, we're going to learn a lot more about game engines because we're going to be using one to make a game. So yeah, that hopefully gives you a rough idea. If there's any questions, I don't see anything in the chat, but again, just feel free to ask any questions and interrupt if you feel confused or you just want something clarified or you're interested in hearing about something more. All right, so that being said, there's a lot of engines out there. There's, excuse me, like many options. So it can be a bit overwhelming. I mean, even just to give you an idea, if I just search game engine, Google will probably give me, you know, a series of results. But if we just go to Wikipedia and we look at the list of it, I mean, you can see there's copious amounts of game engines. Now, a lot of these are sort of outdated at this point. It's just kind of logging sort of the sort of history of game engines to some degree in doing this. Like there might not be a stable release of a lot of these, but nonetheless, there's still quite a few out there. Some of them you might see a game that you enjoyed playing or inspired you to make a game to begin with, or you heard is really cool, or you observed, and it might not even be available to you. You might not be able to use that engine because certain engines, for example, like this one, for example, this is the Source engine. This engine is maintained by Valve, the company that made the game Half-Life. They also made the game Portal, Dota. So if you're familiar with any of these games, you can't use this engine if you don't work at Valve. You would need to work at Valve in order to use this engine. So this is not really something that you could do. But you know, other engines are widespread. They're used by tons and tons and tons of people, and they're accessible to the public to some degree. So I basically listed examples that are publicly accessible, of course, that we might consider using for our first game. So the first one, which I mentioned earlier, is called Unity. Unity is, I mean, a wildly popular game engine. You undoubtedly know of many games created with Unity. It would surprise me, in fact, if you had not heard of a single game that was made with Unity. So yeah, if you're interested to see, I mean, we can take a quick look and see some example games that were made with Unity, but it's not too important. The point is that this engine is available for the public to use, and if it's called Unity Personal. If you're just by yourself and you meet this criteria, so basically, if your game, your game that doesn't exist yet, has less than $100,000 in revenue or funds, so like in case you're being invested in or something like that, then you don't have to pay. It's totally free. So this is a really good option for people that want to make. They have maybe you're really ambitious. You want to make a serious game. You're very invested in doing this. Unity is really cool to get into, and it definitely gets beyond the hobby level. If you want to make a pretty impressive game. It has, as a game engine, it offers a lot of editor capabilities, and it offers a lot of basically really advanced tools for creating assets like icons or images that are used to create characters in your game. It also has stuff for of course, physics and the like. It's a pretty full-fledged tool You can think of this more as a complete tool for making games. So it's very popular for that reason. Yeah, I just wanted to see here. Well, of course, there's just a list of games. I'm not too concerned about looking at all of them, but we can look at a handful of these. Namely, I'm familiar with Kerbal Space Program. That's a pretty big game. I think this was a pretty big game when it came out, All-Star Brawl. So you can just look at this list. Looks like some Pokemon games were made with Unity. That's pretty big. Yeah, I mean, basically, tons and tons of people are making games with Unity. Okay, so Unreal, it's another really, really popular engine. I would say the same goes for Unreal. There's probably tons of games that you are familiar with or didn't realize that are made with the Unreal Engine. Unreal's incredibly popular. You can check out this link that I provided, and it kind of breaks down a lot of the features provided with Unreal. Again, this is considered a very professional tool. There is a visual scripting environment with Unreal, which I'm sure they probably talk about here. Yeah, to some degree, I'm sure. Maybe. But, basically with Unreal, there's a lot of very sort of deep optimization going on. It's built with C++, which is a very, very common programming language that's used across the game development industry. The reason being is it lets you control a lot about the program that you are writing with that language. You can have access to a lot of resources that a lot of other languages kind of hide. And because of this, you can make very, very optimized video games. I think one of the other unique things about Unreal is that they don't have, I mean, of course they have scripting because that's critical for a game engine, but their scripting actually uses C++ as well. So you would need to kind of get familiar with C++ in order to use this game engine, or I believe you can use their visual scripting system, which is kind of like drag and drop sort of stuff. I'm pretty sure. They don't seem to talk about it here, which is interesting. That's what I was looking for, but I don't see it. So in any event, if you're interested in Unreal, you can learn about that. I'm pretty sure Fortnite was made in Unreal because it's owned by Epic Games, if I'm not mistaken. So there's an example. Okay, so these two, I wouldn't really evaluate using for a series like this. They are pretty beefy. They're really big engines. They try to solve tons and tons and tons of problems. And they're also not open source, meaning that I can't go look at the way that they were implemented in all respects. So some stuff I can go look at. Some aspects of these game engines is open source, but a lot of it is not. All of the following three are. And I wanted to mention them at least, even though we only are going to use one, because it's interesting to kind of take a look and break down like why you would use one versus another. Because ultimately, for making your first game, I would say what matters the most is that you use something that you get and it motivates you to continue using it, and you can get your hands on it and work with it to the degree that you want to spend time doing it. That's really the most important thing for your first game. So if you decide to change engines for the next thing you make, or you decide you don't like that anymore, that's fine. But you should not pick an engine just because it's the shiniest or the fastest or something like that for your first game. once you start making subsequent games, you'll know exactly what you need, what you want out of your engine. So it'll be easier for you to make a decision at that point. But I wanted to show these three mainly because they're all open source. So all of the code is available for everyone to see. Everyone can use it freely. You don't have to pay anyone to use these game engines. For Unity and Unreal, you have to pay someone. You have to pay those companies once you reach a certain revenue. So once your game has sold enough copies, once you make a certain amount of money, then yeah, you need to start paying them to use their engine because you're licensing their technology. For these engines, you don't have to do that. They're open source. They'll always be open source, at least to some degree. The code will always be out there. Yeah, so you can keep using them. And people make pretty big games with these engines. So they're definitely not trivial sort of game engines by any means. They're just run or operated by a community at large, a community of developers. So you can look at a blog, one of their blog posts. You can look at their blog and kind of see a lot of the games that are being made with these engines, in particular Cocos. A lot of these games I think look really good. Here's kind of like, I guess what would be considered a pretty big title. So the sort of official, the official Jurassic World game was made using this game engine. There's tons of games for all of these engines that are being created. So it can be nice to go and take a look and see what's possible. But notably, what I would say about Cocos, Cocos, I believe, notice that none of these examples here. So this looks 3D, sort of. I think there's a name for this. It's called like perspective 3D or something like that, similar to this, right? This looks sort of 3D, but obviously it's a 2D game. The reason it's evaluated as 2D is because this surface, this plane, is the game field, and the physics are going to be limited to that plane. I mean, there's other criteria for that, but that's kind of the gist. That's the main idea there, is that basically your game is operating on a 2D plane. The content of your game is operating on a 2D plane. There's no 3D space in which your players are having to navigate and you're having to do physics there. So Cocos is a 2D game engine. So that's another great reason to get started with it. It's kind of cut back a little bit. It's a lot more sort of, it's a lot more, kind of limited in that sense, but I think it's also nice if that's your interest is to make a 2D game, which we'll be doing for this series for sure, because it's a nice space to learn in and work in. And there's lots of possibilities. I mean, I love, how people make these sort of 3D spaces, spaces that have depth and stuff in the game, but are still just 2D games. So it's not like underselling the game. Probably most games you played are 2D games. Anyway, so that's Cocos. You can learn about that. I gave some notes on these more so just because they were kind of contenders in what I was evaluating as far as sort of introducing the game engine. So, Cocos is 2D is open source. The engine implementation, so the software aspect of the engine, the developers that made this, they used C++ to make it. So you see already, Unreal is also written in C++. Unity is also written in C++. Most, contemporary sort of like heavy duty game engines are going to be written in C++ because it's sort of, at this point, an industry standard. And it's great for that purpose. But for scripting, so scripting is separate from the code used to write the engine. The engine runs, and it's got a separate scripting engine, remember. It's got a separate way of running scripts. So the developers can choose whatever they'd like you to write scripts in. A lot of people do allow you to write scripts in C++ because it's very efficient. It means that there's less of a layer between the scripts you're writing and the engine itself. So if you want to make a really optimized game, you might use C++ for your scripts, but you don't have to, which is nice. So with Cocos, you could use JavaScript, which is a web language. This is becoming increasingly popular because people want to play web games or games that can run on the web in the browser, or Lua, which is another very popular language for scripting. In particular for games scripting. It's been around a long time for that purpose. Phaser is one that I came across. This is pretty interesting. It's a fascinating engine if you want to build a web game. If you want to build a web game, definitely check this out. You can create games that are entirely in HTML5 or compatible with HTML5, meaning that the game can just run in the browser. It just basically works like a web page. So you load the web page and it's a game. This is pretty cool. It's lightweight. It's a great way to make a mobile game. You know, basically you can, you can basically, you know, make a mobile game for a mobile browser or a phone browser, and that same game will run on the desktop, on a desktop browser. So this is a really cool way to get into that. Yeah, there's also tons of resources and support for all of these engines that I've listed. I didn't list any engines that don't have good documentation necessarily. So all of these have enough to get you started, to help you out as you make your first game. So this is Phaser. Phaser is implemented using JavaScript. And then for scripting, this should say scripting here at the end. It uses JavaScript or TypeScript for scripting. TypeScript is basically a sort of contemporary implementation of JavaScript. These are programming languages, by the way. Sorry if that wasn't clear. So these are going to be programming languages: C++, JavaScript, Lua. These are programming languages in which you will write software. So that's what Phaser is. Lastly, we'll have Godot, or Godot. Some people call it Godot. I call it Godot because that's a thing already. But I think they kind of meant it as sort of a joke or something weird. In any event, yeah, Godot is a kind of the last engine we'll look at, and I already spoiled it. You know, that's, I think, what is going to be a really good way of getting into games programming. So Godot is a pretty cool engine. It's been around for, I guess, a decade now. You can read about it on the Wikipedia page. Well, I think I probably put multiple links regarding Godot in here. But Godot is a pretty cool engine that has a lot of beginner-friendly sort of resources surrounding it, and it does seem to be catered to the beginning developer experience. So people kind of learning about games for the first time, making their first game, and they want to make a serious game nonetheless. They want to make something that is powerful, uses a powerful game engine. Godot is really, it seems really, really good for that. It's also fully open source, as is Phaser. It's implemented with C++, so it is has really, really solid efficiency in that respect. But the scripting language, the scripting environments that it provides are pretty numerous, which is also really nice. So it's very flexible. in that respect. If you click here, so it's talking about being easy to program. That's one of the big things that they tout, is they made this scripting engine that can run all different kinds of scripting languages. And because of that, it makes it more flexible for people that want to get started more quickly. So if you already know C#, you can use C#, which is pretty cool. That's a language developed by Microsoft. If you want to use C++ and you're already familiar with that, you can get started there. You can use GD script, which is something that the team, the developers at the Godot, or part of the Godot community, created, so that you can make games with a Python-like language syntax. And of course, they talk about, there's extensive reasoning behind why they did that. I actually linked to this article. So yeah, and then there's visual scripting. So drag and drop, you can get an idea of what this looks like here. So let's take a look at some images, just so you can see what a visual script looks like. Actually, let's go here. Let's do, let's hop down here, probably see some pictures at this point. And this is just in the documentation. The Godot documentation is also very, very good. It looks very good as far as being really thorough, really comprehensive. You can see this tutorial just on visual scripting is pretty extensive. There's a really nice step-by-step guide that you can get your hands on, and it's easy to go through. They also link you to videos if that's more your thing. And they have good documentation on all the different aspects of their engine, which are laid out really nicely, so you can see everything that's involved that Godot is capable of handling for you. So things like, there's a documentation for platforms. You can look into getting your game set up to work on mobile, so iOS and Android. These are cross-platform engines, by the way. Most of the game engines that I demonstrated can run on all sorts of things, computers, phones, games made with Godot. I think it can certainly run on consoles as well. So I don't see why not. Obviously, Godot, being a game engine, handles physics, animation, user input, I/O, so feedback to the user. You can make your user interfaces for your game in Godot, like your menus and stuff. Shading, which are going to be part of the sort of graphics rendering system, and networking for multiplayer. So there's really, it's a full-blown engine, and the documents for using the engine are quite good. So all that being said, I think it's a good sort of introductory engine that also people suggest is fantastic for making full-fledged games. Like, there are definitely games that you've probably heard of and are familiar with that are made in Godot. It's definitely a serious engine, and can definitely take you quite a long way. Yeah, I mean, depending on the kind of game you're making too, potentially, forever if you enjoy making games with Godot. So for that reason, I think it's a good choice. So that being said, I basically got started here. I'm also using Godot. This will be my second time using it. I used it very briefly just to kind of learn about it a while back, maybe like 2 years ago, when I was learning about game engines at different points. Yeah, their tutorial is pretty fantastic. So I'm going to be kind of using this as the basis, and then of course we'll be making our own sort of type of game. And hopefully we'll be able to kind of like address probably, maybe less than what this tutorial does in particular, but we don't need to be as thorough. And we'll kind of let the group, everyone attending today kind of guide some of the stuff that we address. That way it's the most productive for the people learning here in this series. But I'll definitely be referencing this myself in my notes and things like that, so that if there's something that comes up that you're interested in or have a question about, I can link you to the tutorial for a more in-depth explanation. But yeah, their stuff is really good. Their step-by-step is quite good. That being said, yeah, we're going to use GD script. I know I talked about all the different scripting options for Godot, but we're going to use GD script. The reason being is that I don't expect necessarily everyone to be, experienced programmers for this course. I will, be writing scripts in class, like in these sessions. I'll be kind of walking you through what I'm doing and why I'm doing it. But, GD script is meant to be a pretty accessible language, and there's a lot of good documentation from Godot on how GD script works and how to use it. If you're familiar with programming languages already, this documentation is really great. It basically tells you just everything you need to know about the language. I mean, it is a pretty long document. Nonetheless, it's not like it's like really small. There's certainly a lot of stuff to be done. But this is, as far as I understand, pretty much all of it. So if you were to read this whole document, you would get a really good idea of what GD script is capable of doing. But we don't really need to do that. We'll kind of incorporate things as we go along the way. And this is really great. I mean, if you're familiar with programming at all, you should be able to read this and kind of get the way GD script sort of is going to be approaching things. For me, it kind of looks a lot like JavaScript, and it looks like C, and it looks like Python. So those are all things that kind of dawn on me as I was kind of looking through GD script to begin with. If you were really motivated and you wanted to use C#, that's another one I would recommend. I actually programmed in C# for about 4 years professionally. So that's actually my, language of choice or whatever. But I don't find that to be the most beginner-friendly approach. And C# is pretty extensive. But for that reason, it's definitely really cool to learn. It's far more widespread. I mean, GD script is only used for Godot. So for that reason, if you're interested in programming in general or broadly, it won't hurt you at all to learn GD script. There's no problem doing that. You learn one language, all of them start to make more sense. So I wouldn't let it deter you at all. But it's nice to know. The cool thing with Godot is that you can use both if you want. You don't have to just have scripts in GD script. So if you decide later, I think I want to start using C#, there's no problem with that. You just have to download the mono version of the engine. So that's kind of important. I put a link in here. I'll close these things. I put a link in here to the download page of the Godot engine. So this is what we're going to be using for the class. So on your computer, if you have access to a computer, you can go ahead and download this. I believe there's actually a web editor, if I'm not mistaken. There is a web editor. It's incredibly limited, I think. Yeah, but nonetheless, you could probably make the game that we're trying to make in this web editor, which is pretty fantastic. So yeah, maybe give this a try if you aren't able to download it on your machine. It's just an option that's going to be available to you, which is cool. I don't really know what's happening. Okay, it's downloading a demo. Okay, that we can load into the web editor. Cool. If I start it though, it's not running. Maybe I have to do 2. Oh, did it block it? That might be something to debug if you're really curious about the web editor. But yeah, otherwise I'd suggest downloading the version here. I'm using Mac OS, so these are the versions available to me. If you're on Windows, so if you want to write scripts using C#, or you think you might, no reason not to go ahead and download the mono version of the Godot engine. It's not going to hurt your project at all if you start with this version and then want to use the mono version later. Yeah, you just would save your project in this version of the editor. You'd open up the mono version and load it, and then you could go on writing C# scripts if you wanted to do so. So they just package them separately as a separate part of the engine. If you're using Linux, there's also Linux versions of both, so that's great. It's a really cool cross-platform engine, so there are tons of possibilities for you to get started with. I went ahead and got the standard version set up on my computer. I guess I could have gotten the mono version, because maybe in the series eventually maybe we could try to write a C# script just to try it out. But maybe at that point I'll try to set up the mono version and then see if it works, like if our existing project works, because it should. So we'll cross that bridge at that point. It's called mono, by the way, because that's like it's called the runtime environment. So it basically just means that in order to use C#, you need a specific runtime environment for running C# code, for evaluating C# code. And that's the runtime environment that's provided. So it's actually, you need these SDKs in order to use it. So standard or software development kits. And funnily enough, you could use the .NET SDK. So there's no reason it'd really be called mono at that point. But anyway, yeah. This is the one made by Microsoft. The mono SDK is made by someone else. I don't remember. It might have actually been Unity, now that I think about it. Or it might have been to do with Unity. But, oh, it's sponsored by Microsoft. Yeah, it's just an open source implementation of the .NET framework for C#. So, yeah, anyway, kind of cool. All right, off of that track. Another reason I think Godot is really cool is it has a really great community. So there's this group called GD Quest. I'm not exactly a fan of their presentation of stuff. It's a little kind of childlike, which is fine. I think it's pretty cool. Yeah, but it is not for children. I mean, if you're a child, you can certainly try to make your own game. Not exclusionary at all. It's this is a fully fleshed series set of resources on how to make games using Godot. Like, it's incredibly successful. It's incredibly popular, and they really are like very well made videos, documents, things like this. Most of which are free for people to use. I've linked a couple of the tutorials here. So this one in particular, so getting started with Godot in 2021. I mean, this is like the most contemporary option for you. It's a series of videos. Each video is pretty short. It basically walks you through what the point of Godot is, how to look at it, and it's going to cover stuff that we'll get to, but it'll probably cover things that we might not necessarily talk about because it's much more in depth as far as Godot goes. Whereas I'm probably going to deal as much as I can with just generally, making games and problems that we'll face, and try to expose you to stuff that way. But this is much more about like Godot itself and how to work with it. So this is really cool. I highly recommend checking it out. Their videos on YouTube are great. They're just really comprehensive. So, this community is pretty incredible. And because of that, it makes me recommend Godot even more strongly. Finally, also Godot is open source. So it's also free. You don't have to pay. Whoops, go back. You don't have to pay for Godot. It doesn't cost money, which is also always great. I'm going to close these. Okay. We're at the end here, but that's okay. We're pretty much done talking about game engines and kind of introducing them. So I hope this has been fascinating or at least informative. I just wanted to point out that these would be tools that you would want to have handy if you're getting started. We already talked about the engine. So you're going to download that. And I'm just providing the download link again, and a text editor. So I have a text editor on my computer. It's called Atom. I like using it. If you see me needing a text editor for any reason, this is probably the one that I'll use. There's tons of different ones out there. There's one called Sublime. There's all kinds. It doesn't really matter which one you use. You just need something where you can open text files and edit them. This last part is just basically walking you through opening the Godot engine software. So we'll do that next time too. We'll open it up. And lastly, really quick before the very end, I have an idea for a game that we will make, ideally. We'll see what kind of game it becomes and if it's very playable, but I think it'll be, pretty fun. But I would be really curious to hear your ideas. So if you have any ideas about the kind of game you want to make for yourself, or if you can think of a very simple, basic 2D game that we might make, I don't know if I think they're better than my idea, which they probably are, then maybe we'll do that instead. So it really doesn't matter to me what game we make. I want to make what everyone else wants to work on, because you're here and you definitely want to enjoy the game you create. So I think that's it for me. Thanks for joining. And yeah. I don't know if you had anything, Jennifer, that you wanted to share. But
I don't see anything in the comments or the chat. I did want to let everybody know that due to COVID and the mayor's rules that he has passed down to us, programming for the rest of January and all of February will be virtual. That is something that is out of my control. But you will be able to meet us on Zoom or on Facebook, because we do stream to Facebook as well and check those comments. Also, the library will be closed on Monday, the 17th for Martin Luther King Jr. Day. So we will not be in the library, and we will be back on that Tuesday. A comment just popped in saying, hi, how long do you think it would take for an absolute beginner to build a decent game?
Yeah, that's a good question. I think, yeah, or okay, oh, I see in the chat. Okay, or what would be a reasonable time frame? I think what I can tell you is all of the factors. Okay, 2D game, right? Yeah. So all of the factors I can tell you certainly that would basically contribute to the time frame that you'd look at. So basically, have you programmed before? And are you familiar with the kind of problems that come up with programming? Do you have a lot of experience doing it? Like, how familiar are you with it? Have you ever created art before, your own art, digital art, anything like that? Have you ever worked with audio before? Have you worked with sound files, sound editing, etc.? These things are kind of the big factors that I can think of offhand that would kind of that you'd want to keep in mind. But basically, I'd say it all depends on how motivated you are, and it depends on how much scope you have. So the first thing I'd say, I seem to have gotten this advice everywhere I've ever read online. Basically, someone will ask this question, and every time there's the top response is like, think of the game that you want to make, like really badly, that you're very motivated to make, and tell yourself that you're not going to make that game because that is not the first game you're going to make. The first game you're going to make is going to be a much, 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 much simpler game. So the advice I've read is try to take the game idea that you have and reduce it down to just the simplest aspects of that game. So maybe 1 or 2 game mechanics. Try to make it, as basic in your mind as possible. And that's the game that you want to try to make. Because you'll have a much harder time trying to pull off your greatest ambition for your first game. Once you finish your first game, you will first of all know far more accurately how long it takes you to make a game, and second of all, you'll feel much more familiar with all of the sort of requirements that are involved, and you'll sort of know what you're good at and what you're bad at. But I would say, all of that being said, I would say someone could make a game spending a lot of time in like a pretty decent game, like you mentioned, a 2D game with a couple of mechanics, maybe conceding on a couple things like the art. Maybe the art kind of is non-existent or not good, or maybe there's not really any sound, etc. Maybe in a month or 2, spending some free time and stuff. But that would all depend on what your personal goals are. Like if you're really interested in sound, you should try to spend as much time on that as you can, and just concede that your game might not look the best and it might not play the best, but it has great sound because that's what you care about and that's what you want to spend time doing. So yeah, it just totally depends on what your expectations are for your game. The lower those are, the better. Yeah, no problem. No problem.
That's all I see. Let me just double check on Facebook. I don't see anything on Facebook either. So thank you again, everybody, for joining us. Again, if you have any questions, you can reach out to Paige during his office hours, Monday evenings, and you can sign up for those right through our library website. Again, we're closed on the 17th, and if you need anything else, reach out to us at X Grid. I have nothing else for you, so you all have a great night.
Thanks. Bye, everyone.
Thanks, Paige.